Welcome to the viewers. Today we discuss an important topic, Laplace transform of derivative. Suppose GT is a continuous function and order of e to the power at and GT is order of e to the power at. That means exponential order of e to the power at t tends to infinity. And if g dash t is piecewise continuous, that means while maintaining all Dirichlet conditions, then by Laplace transform of g dash t is given by p of gp minus g0. Now how to prove it? Now we already left out the all analytical treatments. Just we simply find out these results by the method of byparts, simply using the property of Laplace transform. Just a formula, working formula of Laplace transform, L of g dash t is equal to, using the property 0 to infinity to the power minus pt, p be the parameter, where p is the parameter, complex parameter of the Laplace transform, and here g dash t dt. Now using it is improper integral, so taking it limit as t tends to infinity as a finite form, e to the power minus pt and g dash t. Now using by parts, that means first functions integration of the second minus derivative of the first, that is p into e to the power minus pt, integration of the second, that means gt dt, and taking the limit as 0 to t as whole. So it will be limit as t tends to infinity e to the power minus pt, and it's already clear that it will be g of t if we find the integrations. Not at all necessary to write it here. T tends to infinity, we write here only gt and pt. Okay, minus e to the power 0 and g0, and here also we write plus p limit as t tends to infinity 0 to t e to the power minus pt gt dt. So what will be it? And it's obviously very much clear, e to the power minus infinity tends to 0. So any quantity is multiplied by 0, that will be clearly 0. So 0 e to the power 0 is 1, so it will be z0 plus p into integral 0 to infinity e to the power minus pt gt dt. So that will be very much clear. It will be Laplace transform of gt, that will be gp minus g0. So we can prove this theorem by general method, and we left out all analytical treatments. So another useful results, if we find if the n minus 1th derivative of a function gt, if we extend this formula actually, then if we extend this function, that is if the n minus 1th derivative of a function gt is continuous and as well as its derivative, that is nth order derivative, is piecewise continuous. And that means in any finite interval t, it's a Dirichlet condition. In any finite interval of t, so we can say that ft, f dash t up to fn minus 1 t are each of exponential order. If we consider here gt, so it will be better to write here gt, g dash t, gn minus 1 t. Or simply it is an arbitrary function. You may have take here ft or gt, whatever maybe it is, order of e to the power at at t tends to infinity. Then the Laplace transform of lt will be, let's say, Laplace transform of nth order derivative, that is gnt. That will be clear. P to the power n gp minus p to the power n minus 1 g0 minus p to the power n minus 2 g dash 0 minus, in this way, minus p to the g to the power n minus 1 0, where gp is Laplace transform of gt. It's very much clear results. And if we take by the sum of the simple elementary calculations, if we put in the earlier theorem, if we use it, that means L of gnt, that is nth order derivative, if we take it, then P of L of gn minus 1 t minus g to the power n minus 1, that is nth order derivative of g0, in this way. Similarly, L of gn minus 1 t, that will be p into L of gn minus 2 t, gn minus 2 0. In this way, we can take L of g dash t will be pl of gt minus g0 and L of g double dash t, that is g dash t into g0, into finally this p into L of g dash t is equal to gt minus, here it is g dash 0, so it will be g0. And simply if we are multiplying, if we take here 1, equation 2, dot 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 up to equation 3, equation 4, etc., etc., if we multiply up to 1 to 4 by as 1 p dot 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 up to pn minus 2 and pn minus 1, and then adding, so what will be it? It will be first order multiplied by 1, it will be multiplied by p, and if we add, all terms will be cancelled here, 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 and what will be the last term? And we get the final term L of gnt, that will be p to the power n. It's clear. L of gnt, and that will be p to the power n. Here it will multiply at p to the power n minus 1, so it will be p to the power n gp minus p to the power n minus 1 g0 minus p to the power n minus 2 g dash 0, in this way, and finally g to the power n minus 1 0. It will be the last result. Now all these useful results have been applied to solve few problems in the Laplace transform that will be applied as a working rule. So in this aspect, these two theorems are very important. That means the only result. Sometimes I ignore actually the rigorous analytical treatment, just simply prove as the working rule. Thank you.